our planet hurtles through space, a ceaseless ballet of rotation that defines our days, seasons, and very existence. But what if this rhythm abruptly faltered? Imagine Earth's rotation instantly ceasing for just 5 seconds. This brief pause would unleash forces transforming our familiar world into an unimaginable scene of destruction. At the equator, we're moving at over 1,000 miles per hour. Any sudden stop means everything not bolted down, people, cars, buildings, would continue moving eastward at that speed. Unanchored objects become deadly missiles. Buildings would shear from their foundations, trees ripped from the earth, and anything exposed to the surface would experience a catastrophic, high-speed journey. Our atmosphere, not being rigidly attached, would continue its motion for a while. This creates winds of unimaginable force, far exceeding any hurricane ever recorded. These winds would likely reach supersonic speeds, scouring the planet's surface clean. The resulting sonic booms alone would be devastating, capable of shattering anything left standing. The oceans, sharing the Earth's spin, would surge uncontrollably. Massive tsunamis, potentially miles high, would race across continents at speeds that dwarf anything we've witnessed. These colossal waves, combined with the supersonic winds, would act like a planetary-scale sandblaster, stripping away soil, forests, and much of the built environment. Earth isn't a perfect sphere. Its rotation causes an equatorial bulge. A sudden stop would cause this bulge to relax, triggering massive seismic events and potentially flattening the planet. This immense geological stress would trigger earthquakes along every fault line simultaneously. Volcanic activity would erupt globally as tectonic plates shift and magma is forced upwards. Earth's magnetic field is generated by its spinning molten core. Halting rotation, even briefly, could disrupt this dynamo, potentially weakening or distorting the protective shield. A weakened magnetic field means increased exposure to solar and cosmic radiation. This harmful radiation would batter the planet's surface, posing a significant threat to any remaining life. If rotation stopped permanently, one side would face the sun eternally, baking under unrelenting heat, while the other would be plunged into eternal frigid darkness. The sunlit hemisphere would experience temperatures so high that water boils away, melting ice caps and creating an uninhabitable, scorched desert. All life would struggle to survive. Conversely, the dark hemisphere would freeze solid. Temperatures would plummet to hundreds of degrees below zero, turning the atmosphere itself into a layer of ice. A narrow twilight zone between these extremes might offer a sliver of hope, with more moderate temperatures where liquid water could theoretically exist. Without rotation, atmospheric circulation patterns would change dramatically. The intense dayside heat and nightside cold would create extreme temperature gradients, driving ferocious, unpredictable storms. The powerful tidal forces from the moon and sun, which currently influence our oceans, would behave very differently. Without the Earth's spin, their gravitational pull would be more static. For any life to persist, it would need to adapt to these new extreme conditions. Migrations towards the twilight zone and adaptations for radiation resistance would be crucial. The night sky would become static. Stars would appear fixed in their positions, the familiar daily transit replaced by an unchanging panorama of the cosmos. On the day side, the sun would hang motionlessly in the sky, its constant glare providing no respite or change. Days and nights as we know them would cease to exist. Earth's rotation is a consequence of its formation. As the solar system coalesced from a giant cloud of gas and dust, conservation of angular momentum ensured it spun. This principle, like an ice skater pulling their arms in to spin faster, dictates that the momentum of a rotating object remains constant unless acted upon by an external force. Stopping Earth's spin would require an immense external force to counteract its trillions of tons of mass and its rapid velocity, an impossible cosmic event. Over billions of years, the moon's gravity has slowed Earth's rotation. This process, called tidal locking, has already synchronized the moon's spin with its orbit. Even without a sudden catastrophic stop, the absence of rotation means the atmosphere wouldn't deflect as many small meteoroids, leading to constant bombardment. The immense friction generated from the initial stop and the subsequent atmospheric surge would heat the planet's surface tremendously, like a cosmic brakes-on scenario. The air itself, moving at supersonic speeds, would generate intense heat through friction with the stationary ground and any remaining structures, causing widespread fires. The violent shifts in pressure and massive seismic activity could disrupt Earth's internal heat distribution, leading to unpredictable geothermal events over time. While Earth's mass, and thus gravitational pull, wouldn't change, the feeling of gravity might shift due to the extreme forces and rapid deceleration effects. Over immensely long timescales, the atmosphere might redistribute unevenly, potentially accumulating on the cold side and thinning on the hot side, affecting air pressure. Even a 5-second stop would leave scars. The initial velocity transfer would cause lasting geological and meteorological abnormalities as the planet tries to find a new equilibrium. For humanity, such an event would be an extinction-level catastrophe. Even with advanced technology, immediate survival in the face of global devastation would be nearly impossible. Our concept of a day is intrinsically tied to Earth's rotation. Without it, timekeeping and biological rhythms would be fundamentally altered, if life could even adapt. The daily cycles of sunlight and darkness regulate countless biological processes. Their absence would devastate ecosystems, impacting everything from photosynthesis to animal behavior. The heat generated by Earth's core, a remnant of its formation and radioactive decay, is vital for plate tectonics and the magnetic field. Its activity is linked to rotation. If the spin ceased permanently, Earth would eventually settle into a static state, forever divided into a perpetually searing day side and an eternally frozen night side. This hypothetical scenario, even for a mere 5 seconds, underscores the incredible forces and precise balance that govern our planet's dynamic and life-sustaining spin. It's important to note that any significant, prolonged slowdown or stop would be a vastly more complex and catastrophic event than our brief 5-second thought experiment. The Earth's spin is not just a physical state, it's the conductor of its complex orchestra of weather, geology, and day-night cycles that allow life to flourish. Understanding how momentum works on a planetary scale helps us appreciate the incredible stability and the gentle yet immense forces that maintain Earth's delicate equilibrium. This thought experiment highlights the sheer power of physics and the delicate balance of our planet. It's a stark reminder of how much we depend on Earth's consistent rotation. The consistent spin might seem mundane, but it's the bedrock of our climate, our seasons, and the very rhythm of life. It's a phenomenon we should never take for granted.